Hello world, this is live from QNAP headquarters in Taipei, Taiwan. As always, I'm Michael, and today it's my pleasure to have our product manager, Ripo, with me. Hi, Ripo.
Hello, everyone.
Last time we see you, you were here to introduce the benefit of using an SSD cache on QNAP NAS, right?
Yes.
And today we have something more to discuss about.
Yes.
So today we are talking about how you can make the best use of your QNAP NAS. Speaking about NAS, you would like to have a NAS that are as fast as possible, as reliable as possible, and the capacity is as big as possible. Today we are going to show you how QNAP technologies can satisfy your needs with different leading technology on the market. Right, Ripo?
Yes.
So, all right, let's go to our slide, please.
Okay. Thanks, Michael. So today we are talking about three leading technology of QNAP that can, as you mentioned, bring our customer higher performance, more capacity in protection, and more flexibility in expansion.
Yeah, sure.
So today we are talking about first Qtier port, and second RAID 15 and 16, and finally we will also discuss iSCSI JBOD. All those technology are unique in our market segment, which means no other competitor have such technology in our market yet. So today I will introduce to you all those technology, how they work, and how can those technology provide higher ROI for the customer.
Sure, let's go ahead. So we are going to talk about Qtier, right? First.
Yes.
Right.
Yes. And of course, we know that currently on the market, they have SSD cache, all flash, and also auto tiering. And currently, QNAP, we are more focusing on auto tiering. So what we call Qtier. And why we are more focusing on Qtier is because right now, although we know that SSD price is still decreasing, but every price you buy a 1 gigabit HDD, for example, SSD is still 4 times more expensive. And we believe that it is important for a customer to maximize every value that they use to purchase SSD. So that's why we are promoting Qtier, which I will introduce the advantage of Qtier and what we will bring in the latest 4.3.4.
Yeah, some of our end users might not be familiar with the idea of tiering. So can you introduce what is tiering?
Yes. Of course, Qtier is a kind of hybrid storage system. In this storage system, as you can see from the chart, the data can be separated into high frequency access and low frequency of access. For those data with high frequency access, what Qtier does is that we have SSD tier and HDD tier. When the system recognizes some file or some data has been frequently accessed, it will move those data blocks to SSD tier, while the rest of the data might be put in a middle tier or HDD tier. The benefit of Qtier is that you can enjoy high capacity storage, while at the same time enjoy the performance boost from SSD. As we can see that on the slide, it right automatically move data between different tiers. And from the slide, you can see we have a class-wise that if data access pattern change, the Qtier auto tiering will always detect the data pattern between different files and move them automatically. Another benefit compared to traditional SSD cache is I also write here is that SSD cache will generally need some space in a RAM because you need to maintain a checksum table, so to check the file between data in the cache and the storage. While Qtier, we don't have such memory limitation, so the SSD can be used directly as storage, and you don't require additional RAM to calculate the data table.
So the data I use frequently will be stored in the SSD, which is a faster hard drive.
Yes.
The data I use lessly will be kept in the traditional hard drives.
Yes.
So with faster drive, I can always access the file I frequently use faster, and that doesn't consume any memory usage, right?
Yes. Although we still have a recommended memory for using Qtier for 4 gigabit because the RAM still need to catch some file. But generally, Qtier does not require the RAM limitation. Like for example, even I have a one terabyte of SSD space, I can only use maybe half because of the RAM limitation.
So the RAM, we still have recommendations for how much RAM we should have, right?
Yes.
But that does not constitute a limitation.
Yes.
Yeah, that's very cool because as far as I know, the SSD cache has RAM limitations.
Yes.
So with that, we can fully utilize the SSD space.
Yes, that's correct. And next slide, I want to further discuss the difference between SSD cache and Qtier 2.0. And here, as you can see from the title, our slogan is to replace SSD cache with Qtier 2.0.
Really?
This is very important because generally we believe that IT user might still think that SSD cache and auto tiering have different usage in different scenarios.
Yeah, some people might think the more buffer I have, because I have SSD cache, I have Qtier, and I have a lot of things that all can make things faster. But actually, with the new Qtier 2.0, that's not necessary.
Yes.
You're going to tell us why.
Yes. Yes, the reason as I address here have maybe two different reasons about SSD cache. They have two drawbacks of SSD cache. First of all, I write that we cannot store data in the SSD cache, which is a general drawback of such configuration. Because as from the chart, you see that the space in SSD cache will always is copy data from the storage to the SSD cache, or data write to SSD cache, then flash to the HDD storage. And in this condition, as you can see from the chart, that the total space that user can utilize did not count the space of SSD. And while the other hand, the Qtier, because SSD is also a tier, it can also consist a data rate. So the total usable space for Qtier have including the space in SSD, which is a very good advantage, because while we know that SSD space may not be enough, but more space is better, right? And
Yeah,
users always seeking for the better way to improve the ROI when they purchase storage. So the first advantage of Qtier compared to SSD cache is that the space in SSD can also be utilized.
That's cool.
Okay. And we further there have second drawback of SSD cache. As we know that although we have different vendors on the market, but usually when we configure SSD cache, we will have a bypass block size. Why we have this configuration? Does anyone ever think about it? While as PM, we know that why we have this configuration is because when you use SSD cache and you have a lot of screenshot assets, for example, 4K video, while you write so many data into the storage, it will all be stored in SSD cache first. And when the SSD cache is full, it will continue write data to the HDD storage, and at this time, the SSD cache will become useless.
Yeah, because the whole purpose of using an SSD is to accelerate those random read and write.
Yes.
So if you fill your SSD with all this sequential data, and you will render useless.
Yes. So this is why the major vendor on the market will have the bypass block size, because they wish that user can bypass the screenshot access, data access to the storage, so that only random data will be stored in the SSD cache, so the performance boost can last longer. But in this case, combining with the opinion that we confirm is that SSD cache is more focusing on the short-term performance boost. While you write so many data in your SSD cache, in the end, when you fall, all the data will still need to be write in the HDD storage. And compared to this drawback, what we want to have for user is a package, a total solution that can also solve this difficulty. So here, although Qtier 1.0 may also have another drawback, is that people may say that auto tiering is not real-time performance boost because you need to calculate access pattern. But right now with Qtier 2.0, we wish that we have added feature such as I/O awareness, which I will explain more further, and tiering on demand. Those two new features in combined, as the chart we can see, we want to let the Qtier have a more intelligent mechanism inside the system. So as we can see that from the green arrow is that screenshot asset will be stored in the HDD tier first, and when necessary, user can decide whether those screenshot data need to be put into SSD tier for boot out the performance, while the random data will be stored in the SSD tier, and we also have a reserve space in that tier, so the Qtier can also handle burst I/O in real time. So with this solution, we hope that Qtier 2.0 can replace SSD cache because it can be used for both short-term and long-term performance boosts.
All right, that's very good. And you have just mentioned that Qtier 2.0 has I/O-aware mechanisms. So what does I/O-aware mean?
Okay, here I will want to introduce about what we call I/O-aware. Is that in Qtier 2.0, we want to, as I mentioned, we want to have a total solution that can satisfy both screenshot and random I/O. So we want the system be able to recognize those different access patterns and allow Qtier to put screenshot access into the HDD tier first and random access and boost I/O into SSD tier first, so that it can better handling the asset or requirement from database or VDI application. So from this chart, we can see that not only we have a lot of systems have the ability to recognize between different access patterns, we also have a reserved space specially designed in SSD tier, which is reserved for random I/O. So compared to the Qtier 1.0, which don't have this reserved space, so that data only move by schedule. In this Qtier 2.0, those blue block is a reserved space, while we can see from the chart that whenever they have a random burst I/O, the system will recognize them and move them automatically to the reserved space. So that in this condition, besides from the scheduling pairing, the Qtier 2.0 also have the ability to adjust the storage performance in real time. So that the burst I/O, random I/O will always be put into the reserved space to pull out the random performance, while the screenshot data can be put into the HDD tier first. And when user need to frequently access those data, it can also be moved to the SSD tier as well.
So basically, it's like you have already integrated the SSD cache feature into the Qtier.
Yes.
So you don't have to keep another SSD cache partition or volume layer, because it already include the feature to accelerate those burst I/O operations.
Yes. As in the starting of this slide, we mentioned we want to provide the storage that have a higher ROI, and we also always know that SSD is more expensive. So we don't think user were willing to have a SSD cache while have Qtier in the same time. And we have developed this solution because we want that Qtier 2.0 can satisfy both requirements.
That's very efficient way to keep both sides of benefits and to maximize your return on your investment.
Yes.
All right. That's very good.
Okay. In the next slide, I will also like to introduce the Qtier 2.0's tiering on demand. This feature is also very important because, as I mentioned in the before, for example, SSD cache, it will need user to decide which block size you need to bypass, so that the SSD cache can be used only for key application. While the Qtier 1.0 doesn't have such mechanism, it might be worse than SSD cache when it comes to so many useless data, but nonetheless be frequently accessed. Those data will also occupy SSD space. But for IT manager, we always want to prove out the key performance with SSD cache with Qtier. So in this Qtier 2.0, we have developed this tiering on demand, which means that user can actively decide which share folder or which iSCSI I want to enable Qtier, while the rest of the folder will be locked at HDD tier and will not occupy the expensive space in SSD tier.
Well, that's very convenient. It's like I have a NAS in my home and I use it for maybe business purposes, and I also store some photos when I travel. And I can set up the NAS to only accelerate the business data,
yes,
and not accelerate those family photos of thematic photos. So only the most important part will be accelerated.
Yes.
So that will guarantee your investment will be the return on your investment will be maximum to only accelerate the thing you really want, and
yes,
only utilize those SSD space to the file you really need to be accelerated.
Yes. With this feature, we believe it will be a more feasible solution for user because instead of SSD cache, which use bypass block size, which general users don't even know how to set up. This Qtier 2.0, you simply just select which share folder and which line you want to boost with Qtier 2, and the performance will increase right away.
Yeah, that looks a lot easier because it's easy to see what kind of file are stored in which folders.
Yes.
But when you see the bypass, block, size, and someone may not understand that.
Yes. Also, I have prepared a small demo here so we can show the power of Qtier 2.0 with Carry on Demand.
Sure, we always like demos. So let's go to demo, please.
So this is our new 4.3.4 UI, and first of all, I want to introduce to you our new storage and station. And here I will demonstrate this NAS we have both Qtier and SSD cache configuration. As you can see, those square mean SSD and the row mean HDD. Here S1 and S2 I have created with this two to form a Qtier storage pool. While the S3, S4, and this 3 and this 4, I have formed another independent storage pool with SSD cache. So here I want to compare the Qtier performance and SSD cache performance as well as demo the Carry on Demand. So while seeing in storage, we can more easily see the difference in file station. So in file station, you can see I have a cache volume which has a cache share folder, while I also have a Qtier volume with folder that have either enabled the Carry on Demand or disabled the Carry on Demand. For example, this Qtier folder has enabled Carry on Demand. We can see a small icon here. And while on the other hand, this no Qtier folder has no Qtier is not enabled on this folder. Also, we can easily enable auto tiering on this folder just in file station.
Oh, that's very straightforward.
Yes, but right now we will not enable it because I want to compare the performance between those two folders.
Sure.
Okay. So let's go to I have prepared two virtual machines to test the performance internally. As you can see, I've created a Qtier VM and cache VM, which we'll use to test the performance between the Qtier share folder and cache share folder. So let's move to the first VM. This is demoing the Qtier folder. So before demoing the performance of Qtier folder, let's just see the performance of a no Qtier folder. So let's start. In the beginning, you can see it's very fast with a memory buffer, but you see the performance quickly drop because system recognized this folder has not enabled Carry on Demand. So the rest of the data will be put into the hard drive, into the HDD tier directly. Okay. Let's wait for its read performance to complete. Okay.
It takes some time.
Yes, because the HDD tier is more slow. And next, we just go to the Qtier folder, and we will do again this test to see the difference.
Sure.
As you can see, compared to the no Qtier folder, this Qtier folder have better write performance.
Yeah, before that we have 400 something, right?
Yes.
Now it's 650.
Yes, because this is how our system recognizes that although it's screenshot assets, but because SSD tier still have free space, so to maximize the space in SSD, those screenshot assets will still be put in the SSD tier. Okay.
Very cool.
So next we move to another VM. This VM will test the folder that is a cache folder. So let's start the test. In the beginning, it's still very fast, but you can see performance is quickly dropped to the same level as the no Qtier folder.
Yeah, dropping rapidly.
Yes, even stop. Okay. So let me just skip this part, and it's more wow, right. 200.
I will have 400 something. Now it's only 200.
Yes, and I must clarify that this is not because our SSD cache is worse than the other vendor. This is because I have intentionally changed one setting in the SSD cache. Let's go back to the storage system and open this storage and station and cache. When we set this cache storage, as you can see, I have set the bypass block size to 1 MB here. So this means the system will not put the screenshot data test into the SSD tier because I have select 1 MB here.
So basically all the data are just going directly to the traditional hard drive.
Yes, that's correct. If I see the bypass block size to none here, I have personally test that the SSD cache performance will be same as Qtier 2.0. Yes.
Yeah, that's understandable.
Yes. So let's go back to the slide. So I just demoed the feature of tiering on demand, that the performance difference between you have a no Qtier folder and a folder that have Qtier, or have another cache folder which user may not understand the bypass block size and select the wrong bypass block size for his application. We know professional IT can still utilize SSD cache, but for general user, this is why we have the slogan using Qtier to replace SSD cache. Because the system will more intelligently decide the correct pattern for your usage.
Yeah, it includes more feature, and the general user doesn't have to worry about if I am setting the right thing, and just have to install it, enable it, and the system will take care of it.
Yes.
Right. So with all these benefits, I really want to buy two new SSD drive and install on my NAS. So what should I do?
Yes. The Qtier port can be easily set up, and I also have a good news that I need to share with you. That,
oh, really?
Yes. If you use our QNAP NAS, and before you don't have Qtier, but you don't want to just back up all your data and delete your storage port, right now in 4.3.4, we will allow you to directly upgrade your storage port into a Qtier storage port.
Well, that's very convenient because I don't have to buy a lot of external drives and back up all my data to them.
Yes.
So I can directly upgrade them to the Qtier pool.
Yes, correct. Right now, as from the title, we write that a storage port created after 4.2 can all be upgraded to a Qtier storage port, and also you can have your Qtier port either by additional SSD or using our QN.2 expansion card, expansion unit, or you can simply remove your SSD cache service while using the SSD that be used as cache to turn it into a Qtier.
So all these conversions are very simple, right? Because general users would expect a lot of a smooth and simple transition.
Yes. The step I mentioned can be simply concluded into three above steps that I mentioned on the slide. First, you just disable your SSD cache, and I must mention that the SSD cache can be disabled online, so it will not affect your storage service. While in the second step, you just open the upgrade to Qtier wizard and confirm the SSD that you want to add to the existing HDD storage port. And finally, you just press apply and wait for 3 minutes, and the storage port will be upgraded to a Qtier storage port.
Well, that sounds very convenient because your file server it will be kept running, and all these upgrade steps are very simple. Just have to click, and within seconds or minutes, you're done.
Yes, as you can see, we have improved UI in 4.3.4, and you can see the upgrade to Qtier wizard is very easier for users to understand.
Yeah, you have logos to distinguish from what drive are you setting, which pool are you setting.
Yes.
All right, very cool. So we have clearly passed less abstracts from a faster file access, but we will have another bottleneck, which is the network performance. So I know we have more 10 gigabit ready model, and we are even doing some 40 gigabit models. So will that help our file access performance?
Yes, of course. Here I want to address another question that may be asked by professional IT is that when we compare auto tiering to SSD cache or full SSD storage, we might think that auto tiering performance might be slower because it did not move the data in real time. So if we don't have the IO awareness, maybe Qtier storage port, the performance will be same as the HDD storage port. And I must clarify that we currently Qtier 2.0 design, this drawback will no longer exist in our Qtier. As you can see, that I have used existing model that already sold on the market, TVS EC 2480, and this model I have used 12 SSD and 12 HDD to build a Qtier storage port. And this storage port I have used 5 BN to do the IO meter standard 4K random read and write test. And as you can see from the slide, the result is very impressed because I must happily announce that in 4.3.3, which we also show during the compute test, we have combined with the NAS iSCSI solution, which will boost the storage performance to 16%. So, for example, with this configuration shown on the slide, we can have a high, so the IOP is not so high, nearly maybe is 20,000, close to 20,000 IOPS. Yes, with 14 terabyte of storage, and all the response time is within 1 millisecond. I know some inter-level for SSD storage have also clearly have a 20,000 200,000 IOPS, and this is what we get when we combine the Qtier storage pool with iSCSI solution and 40 gigabit solution.
So basically, we can use a lower budget to achieve almost as the same fast speed as an OSSD NAS, right?
Yes.
So that's very impressive because OSSD arrays are very expensive, right? So compared with this will be more wise choice.
Yes. So finally, I concluding this topic is that why we clearly have the leading tiering technology in the industry, because in this market segment, we are a unique vendor which provide a Qtier technology, and we are not satisfied by just providing an auto tiering solution. We also want to improve it so that users don't need to use SSD cache. They just need to use one solution, and while the random performance or sequential performance can all be increased. So here I want to summarize our Qtier 2.0 have advantage of SSD as storage, which means SSD space can also be used to store data. And also the Qtier 2.0 with the IO arrays, it can satisfy both sequential access and random access without with the tiering on demand, so you no longer need to use the bypass box size setting or the other
complicated configurations.
Yes.
You can skip that.
Yes. And the user's case, except from the Qtier 1.0, we recommend user to use it with file server, mail server, web servers, because they are all event trigger and the system can calculate the asset pattern. Right now in Qtier 2.0, we also recommend it that user can also use Qtier on more business critical applications such as VDI hosting or even database, because we have the IO arrays mechanism which will act just like SSD cache.
All right, very cool. So Qtier took care of our first concern. That is, we want our NAS to be as fast as possible because we have already improve the performance to almost close to an OSSD array. So that counts our next question. So how do we protect those data? Well, because we want our protection to be more thorough as possible. So some of our users may buy a lot of disks. They think maybe a lot of disk will give them a lot of protection, but it's not like that, right?
Yes. So here come to our next topic. We will introduce RAID 15 and 16. We have first developed this function because we find out from the internal study, we found out that RAID 5 and RAID 6 is actually not suitable when you have more than 8 desks to form a RAID group.
So when you say not suitable, why? Why is it not suitable?
Yes, and here I want to display a table that's really scary when we first look at. Because before, we also have a 12-base or even 16-base NAS, while we only provide RAID 5 and RAID 6. While from the internet, we can see a professional website called Server the Home that have a RAID calculation. And inside this calculation, when we use more than 8 desks and higher capacity, we can see that the real fail possibility within 5 years can increase from 1% to 1%. 1% is really a high number compared to 5 years, because maybe even in 100 users, they will have one user that is will fail within 1 year.
That doesn't sound very cool.
Yes, and if you have 12 drive, the fail rate even increased to 6%. This is just too scary.
I don't think it's acceptable anymore, because if I'm a decision maker, I wouldn't want to purchase such of things, because if the fail rate is too high, I have to spend a lot of more money or dispatch more personnel to take care of that faulty system. That's not acceptable.
Yes, when we first see those numbers, we are also very scared because we have a higher capacity NAS that we already saw on the market. We don't have a solution for such condition. And why the more when we have more disks, the RAID will fail more easily is, for example, if we have a RAID file and one disk is failed, we start a review, everything is okay. And at this time, if second disk fail and the whole RAID will be dead. So that's why both this number and this capacity will contribute to a RAID fail probability.
So actually, when you have more disks, the tolerance for error is dropping.
Yes. So this is why we starting to study the enterprise solution about RAID 15 and 16, and we believe that it is necessary that we porting this technology from enterprise level to SMB level because our customer is major small and business customer, and we want them to have a full protection on their data and storage.
Yeah, that's always our top priority.
Yes. So here, let's see how RAID 15 and 16 can reduce the RAID fail probability. From the same table, we can see by using the QNAP RAID 15, we see the chance of failing from 6% drop back to 0.6%. Why we can decrease the RAID failing probability is because we separate one big RAID file into several sub-array, and this several sub-array will have an independent RAID fail probability. So that's why we can reduce the chance that RAID might fail. And also compared to RAID 10, which use half of this capacity to do redundancy to protect your data, the RAID 15 and 16 allow administrator to use this space while provide accessible RAID fail probability.
So you are looking for a best balance between the capacity and the reliability.
Yes.
Right? So RAID 50 and the RAID 60, they can provide this better protection, but you only also have to utilize less space to protect them.
Yes.
So you have more usable space.
Yes. When discuss about RAID protection, we will always want to focus on that the NAS is not backup. You still need to have an additional backup unit to back up your data.
Yeah.
But if you only have one unit and that unit have more than 8 disks, we strongly recommend users that after upgrade to 4.3.4, maybe we should change the RAID file, one big RAID file RAID into RAID 15 and 16.
So if you cannot afford another NAS, at least better protect your data with RAID 50 and 60.
That's correct. Okay, so we have discussed about why we need to develop RAID 15 and 16. While during the development phase, we also find an interesting fact. Compared to protection, performance is second priority, but it's also very important.
Yeah, of course.
Yes. While developing RAID 15 and 16, we find out that because we have more sub-array, and those sub-array will form a big RAID 0, and compared to one big RAID 5, those sub-array will distribute the RAID parity calculation between multiple RAID. So compared to a single bit RAID, the write performance might be faster when you use QNAP RAID 15 and 16.
So you are distributing all this parity calculation task to different drives. So you can because all the storage tests will not be focused on one single disk.
Yes.
So your performance will be increased.
Yes. We know that when the RAID doing the protection, we will need to calculate the priority. While for HDD, there is generally this different, but we have testing on the full SSD storage. For example, you can see that we have a RAID 15 with 3 subgroup, which is consists by SSD, and compared to one big RAID file, we find the random 4K performance can increase to 300%.
Oh, that's a lot of them.
Yes, because when you use SSD RAID, the SSD RAID will already calculate the RAID priority protection faster than HDD tier. While you separate it into 3 groups, so 3 groups will calculate the RAID parity in the same time, which is why we can increase the random write performance with RAID 15 and 16 with SSD.
So protection first, but when utilizing RAID 5060, we think we can still get a very good performance increase.
Yes, this is more obviously in SSD than in HDD. Actually, in HDD, we find the difference might be small or even do not have such difference because HDD is generally slower than when compared to RAID protection. But if user using a full SSD solution, we will recommend them. Besides from RAID 10, there's right now a different option for them to use.
So how do I choose between all these RAID options?
Yes. Here I have summarized a table that compare between advantage and disadvantage between different RAID configuration, but different from general public soft. I want to promote an idea that RAID 5 is just suitable for backup because we know about 30% of users still use RAID 5 for general data storage. While as I just mentioned, RAID 5 might not be suitable for general data storage because one disk failed, another is failed during review, and the data is lost. So right now we are promoting use RAID 6 for NAS that have less than 8 bay. While if a NAS have more than 8 bay, we will recommend them starting to use RAID 15 for high frequency backup, or RAID 16 for general VDI hosting, or the general file server or video editing.
So based on the usage and the application, you can choose the most suitable RAID configuration according to the criteria we provided.
Yes, and of course RAID 10 is still is highest RAID performance. RAID 10 we still strategically recommend for database or the other critical business storage. But RAID 15 and 16 can also be utilized if you want to use more space.
So let's again another balance between your performance and your storage space.
Yes.
And all this efficiency stuff. You just have to balance between all the conditions.
Yes.
So can we combine those RAID 5060 with our Qtier solution, because we just mentioned those two things, and it just occurred to me, if we combine them, can we get a more powerful storage space?
Yes, of course. You just mentioned a good point is that IT professional will always think that there's always some drawback in one RAID configuration compared to the other. Either it has a higher performance or higher capacity. Those two cannot be integrated into the same advantage. While combining RAID 15, 16, and Qtier, we can achieve a super storage system that have the both advantages of different RAID group. So I know that we have announced RAID 15 and 16 maybe in the first half year in this year. We have already have put a lot of attention because we want to let Qtier can also be utilized with RAID 15 and 16. So that's why our development process continually delayed, because we want to have the best solution for our user. So as you can see, compared to HDD RAID 15 and 16, we can also do a SSD RAID 15 with HDD RAID 16 to combine it into a super Qtier storage that have both high capacity and high performance. You can even use SSD RAID 10 with HDD RAID 16 if you want.
So with all this time, we have been improving our product just because we want to bring a best combination of speed and the capacity and the reliability to our users.
Yes, we have continually developed features such as snapshot Rubicon, and list RAID 15 and 16 with Qtier because we want to provide a total solution for our user in the same time. Right. So here, let's go into a demo, and I want to show quickly how this RAID 15, 16 with Qtier can be configured inside our NAS system.
Sure, let's go to demo, please.
So in this storage system, you can see the NAS host. I have maybe 12 SSD and more SSD as free drive. While on the other hand, I also have an expansion unit. In this expansion unit, I have additionally another 12 HDD drive. And by combining NAS host and expansion unit, I want to host a super storage system. So we can see in storage destination, let me check management of this managed storage port 2. You can see this storage port is very big because you have so many RAID array. You have first 3 15 subarray is for the iSCSI tier, and each subarray have 4 disks, and the rest 2 RAID group is RAID 16 subarray that is consists by HDD storage, and you can see this storage port totally combined have 5 RAID group, and they have all be consist into a big Qtier auto-tiering storage port.
Well, that's basically you just combine the disk you want to use, and you can always distribute them between different groups, and just build the super storage you want.
Yes, this is why we are very focusing on combining Qtier and RAID 15/16 solution. And there has also a small feature that we will introduce in 4.3.4 is that from this RAID management, you can see right now the user can decide the RAID resync priority. With this setting, when the RAID is doing review, you can select even, for example, server first, which the RAID review speed will be stored so that the NAS storage can still satisfy all the service requirement. While you can also select between this we call resync first. This will allow the RAID group to using almost all I/O focusing on the review process. So this feature can also reduce the chance that a RAID will fail in the end because it speeds up the RAID review speed and decrease the chance that another disk will fall during RAID review.
So you can decide how fast a volume or pool to be rebuilded. So if you give full priority to the resync first, and you can just recover from a disaster pretty quickly.
Yes.
To avoid another disk failure during a rebuild.
Yes, this is additional feature that we will provide for 4.3.4, and overall we just want our customer can decide when his NAS is more than 8 big and need data protection, you can decide to use RAID 15/16 even with Qtier, and release resync priority. They can adjust those settings based on their management style.
Well, that's very impressive because we're probably already talking about a very huge super storage pool combined with performance and reliability. So let pretty much solve the second concern I just raised, because I just said we want fast speed, we want reliable storage space, yes. And now we have reliable storage space. But here comes the last question for now, because if I really have a lot of data to store, and how would I expand my storage space? Because I know the hard disk space on a single NAS will be limited. It cannot always be unlimited expanded. So if those storage space is not enough for me, how can I further expand my storage?
Yes, that will bring us to the next topic, sure. iSCSI JBOD. Let's switch to the slide first. Okay, so the next topic we want to discuss about is iSCSI JBOD, an expansion solution with highest ROI, with highest return on investment for our user. And why we are doing iSCSI JBOD? First of all, I want to focusing on, we are not doing JBOD just today. We have to do it for maybe the JBOD function has already been announced for 1 year. And why we doing this JBOD is actually because before JBOD, we have a special feature that the other storage vendor might not have, is iSCSI initiator. We always know that different storage vendor will try to satisfy the customer iSCSI requirement, so they will allow their storage system to be iSCSI target, which the space can be freely shared to the application. But why our NAS also have a iSCSI initiator feature is because we are more creative and we want users to better utilize our NAS when purchase it. So for example, on this chart, you can see we can our iSCSI initiator feature allow us to mount additional storage unit, whether it's from QNAP or whether it's from the other storage vendor. We can utilize the free space provided by the other storage vendor to create a shared folder, a space in our QNAP NAS that can be utilized. And because this iSCSI initiator, we want to further expand the possibility to allow our NAS to better utilize the storage space from the other NAS. That's why we developed this iSCSI BJ feature.
So it's like we're using the iSCSI feature the reverse way. Usually we create a LAN on the NAS for a computer, maybe a remote server, to mount that LAN to expand the storage of that computer or server.
Yes.
But now we are using it to mount another LAN on another server to use it as the NAS storage space.
Yes.
Well, that's very cool because you can pretty much unlimited expand your capacity.
Yes. In this slide, we can see that iSCSI is a general industrial standard. So with iSCSI initiative feature, our QNAP iSCSI initiative can be used with those brands that we all well know about. For example, ENC, NetApp, Synology, QCell, all those storage vendors iSCSI target can be mounted into a QNAP system as storage space and share folder. So that means if user have unused space provided by the other storage vendor, we can utilize them and allow user to enjoy the intelligent feature that we provide in QNAP NAS, for example, such as Q search, Q filing, and high-speed backup sync.
So once you have a QNAP NAS, it doesn't matter the other LAN is located on servers of various brands because you can always mount them to the QNAP NAS because we are utilizing the industry standard protocols.
Yes. There's another topic I want to address recently because we have a lot of users recently on the internet is asking about the difference between our file-based LAN and block-based LAN because we know our major competitor Synology, they have disabled the block-based LAN. Yes. Although they have some advantages in file-based LAN as well, and we still try to support both file-based LAN and block-based LAN, there has some important reason in this. So I also want to focus that in this live streaming. So first of all, when we see what advantages block-based LAN can provide in our QNAP NAS system, is that it can easily allow an IT admin to locate and manage the space. Because we see that the file-based LAN is created inside a volume, so it is usually harder for IT admin to see the space usage in a iSCSI in a file-based iSCSI LAN. And furthermore, in our block-based iSCSI LAN, it also supports advanced virtualization features such as VAI or Microsoft ODX. And those features can all be supported with block-based LAN, while in our NAS, the file-based LAN is not supported. And finally, we have recently discovered that want to share. We also share with the user. We still need more tests on this but we find out that compared to file-based LAN, which creating in the volume, the block-based LAN can be more released. Can provide more stable performance compared to file-based LAN because it is generally separate from the file system. As we can see from this chart, is that because the file-based LAN is in together with a shared folder, so when the volume and file-based iSCSI LAN are both being used at the same time, the I/O request might be interrupted. Even in the end, it will all go to the storage port. While block-based LAN, on the other hand, will not have such interference.
So you're saying a block-based LAN will have better performance or more stable performance? Are you saying that?
Yes. In the next slide, here I want to say our block-based LAN can probably provide more stable performance because the reason I addressed above. While the file-based LAN and block-based LAN does not have many performance difference inside our NAS system, here I also want to have a demo to show why block-based LAN can provide higher, more stable performance to the user. Because from this chart, we can see in the next demo, we will focus on the maximum response time. Maximum response time compared to IOPS, what we say regarding storage performance, is just like a car. The car has a maximum speed, but it also requires some kind of maneuvering, which the car racer need to better control the storage. So the maximum response time is just like maneuvering power inside a car. It's that if you only have higher performance, but you have high latency, which means that almost every lot of the I/O requests will still be pending or cannot be accessed. For example, Microsoft and Oracle both can run a application require the maximum response time within 15 milliseconds. So in the demo, we will show while writing data to the volume, how it will affect the performance, the stable performance of block-based LAN, and how block-based LAN can be different from this in this scenario. So let's go to demo.
So you're saying that with those reduced maximum latency, that we can better utilize those space, because I know some of the database applications, they might require the disk to respond in a pretty short of time.
Yes.
So with too much latency, it will be dropped, right?
Yes. Screen is changed.
Sorry about that. We have a little bit glitch, but we can go back to our slides first. So let's do our demo later.
Okay. Okay, let's continue and do our demo later if the technical problem can be resolved. So we lost because we call our block-based LAN is might be better than file-based LAN, and we want to continue improve our iSCSI initiator solution. That's all two reasons why we want to provide VJBOD. Because as you can see from this slide, we have the slogan. We want to use how to use iSCSI VJBOD to replace traditional iSCSI connection and JBOD being used to expand the NAS capacity. Because we have several drawbacks related to NAS plus iSCSI target and NAS plus JBOD. First of all, when you use NAS plus iSCSI target, we have recognized that compared to the general expansion method, iSCSI target and NAS is generally more difficult for the IT administrator to see the storage condition and configuration inside the iSCSI target. That is one drawback that we think need to be fixed on the management aspect. And another drawback regarding NAS plus JBOD is that the traditional JBOD have only limited port, so which means you can only depending on the NAS unit that you purchase, you can only have one JBOD to 8 JBOD is depending on the NAS model. Well, how can we combine those two solutions which have a good interface in information syncing that allow user to best management the expansion unit, while at the same time it's not limited to the physical port. So that's why we wanted to develop the iSCSI VJBOD feature.
So because the physical ports are limited, so if I want to really expand my capacity to a very great amount, and then my ability to do that will be limited because I don't have so many ports. So we try to solve this with the network, right?
Yes.
All right. I was told our video system is back online, so can we try to switch to demo again?
Okay. So let's go back to the topic to compare between file-based LAN and block-based LAN. So first of all, I want to show our configuration here. So this is we are using a 1.6 certified ARM-based NAS. In this NAS, we have both block-based iSCSI target and file-based iSCSI LAN. So you can see the first is block-based iSCSI LAN, and this one is file-based iSCSI LAN. And in this system, we do not use cache or Qtier because we want to show the real performance of HDD. And so here you can see in our storage system, we have a block-based iSCSI LAN, and here inside this data volume one, we have a file-based iSCSI LAN here. So what I want to do is we will transfer the data inside the NAS while at the same time using an iometer to test the performance difference between block-based iSCSI LAN and file-based iSCSI LAN.
Wow, real-time performance test, huh?
Yes, it's very risky to do a real-time performance test because I don't know what the result will be. But in any case, anyway, we just start this two iSCSI LAN. As you can see in this server, we already host to QNAP iSCSI. This is block-based iSCSI LAN, and this is file-based iSCSI LAN. And inside, you can already see our iometer test file is about 16 gigabytes, which ensure that it will bypass the system cache. So all the performance show is real performance of HDD. So it might be slower, for example, just maybe 600 IOPS, but we don't need to be surprised because it is a pure HDD performance. And next, I'll go to see our iometer setting. So here I will just use a worker, and here also have an access pattern of a standard 4K random write access pattern, as you can see from here.
Sure.
So here I will try to test the performance difference between file-based iSCSI and block-based iSCSI. First, without writing any data into the data volume. So let's select this QNAP iSCSI file-based run, and let's just run the test for a little bit. Okay, so you can see the LPS of this pure HDD run is generally maybe about 300, 400, and if sometimes it's not very stable, but generally just 300 or 400. And average IO response time is maybe about 13 milliseconds. Well, one thing we want you to focus on is the maximum response time. We say that maybe 15 milliseconds is not accessible. While without SD cache, this is a real HDD performance. So we generally recommend user to use SD cache or Qtier when they need to deploy storage with applications such as database or VDI. But here, I will just want to highlight that the maximum IO response time for this file-based iSCSI is sometimes about 13, 40, but sometimes it goes to just 100, 200. It's not very stable.
Yeah.
So next, let's go to see the block-based iSCSI to see how the performance is different between writing any data file into it. So here, I start the test.
Yeah, with all the same conditions.
Yes. So with all the same condition, we see the total IO per second is okay, seeing a little bit better, but still maybe 400, 500. So it's generally the same as file-based iSCSI. And also the average IO response time is also the same, about 10 seconds. But what's important here is that without the file system, we see the maximum IO response time is generally between just 13 milliseconds. Oh, it just dropped out a little bit, but most of the time it will go only in this range. So we consider this might be one reason why block-based run might be more stable than file-based run. And let's start the test here. And next, I will start to write some file into the volume where the file-based run is located. See how it affects our storage performance. So here you can see that I have prepared a 40 gigabits file, and I just want to copy this file to the same destination here to let this volume starting to read and write data and see how it impacts the storage performance. So I just pause here. And we see that the data is already starting to be transmitted. And let's go back to the demo, the team viewer. And at this time, we will check again this file-based run and see how the performance has been impacted. So you can see from the beginning it's all the same, but this maximum IO response time, sometimes we see that it's more frequently will go to number more than
3-digit
100.
number.
Yes.
It goes to 3-digit numbers more frequently.
Yes. So although the performance is not changed, but we see that it go to a 3-digit maximum IO response time more frequently. While this is one we consider that when you combine the volume with a file-based run, and even more file-based run, it might interrupt the performance.
Yeah, so if you want a better performance and more stable response time for more time-critical applications, such like databases,
yes,
you might want to separate them. You don't want to put them on the same volume.
Yes, we generally don't recommend to put so many iSCSI run in the same volume because of this phenomenon. So next, let's go to select this block-based QNAP iSCSI run and see how is the performance difference. Okay, you can see the performance is the same, and sometimes it just still go to 3 digital at the beginning. But it's more likely that the maximum I/O response time L it will keep at maybe 2 digits or more frequently than the 5 days long. In the beginning, it's still just jumping here and there, but we see that it's more stable now. It's more stable at maybe about in 2 digital currently.
Yeah, so basically you're getting a more stable performance. It still jumps back and forth because it's on the same storage pool, right?
Yes, this cannot be avoided because we still have both block-based and file-based iSCSI on the same storage pool. It's not possible that we turn out to have another storage pool in just in this time. It's just like magic. But for this, we can see that the block-based runs seem to be more reusable when the volume is being used for the other I/O assets. That's one reason that right now I cannot say for certain, which we need to study further. But right now, it seems that the block-based run is more suitable for iSCSI business critical service because it can resist the file system interfering.
So nevertheless, but it's still very important when you are planning your storage space. You need to consider what kind of use case you want to deploy.
Yes.
So you can just separate those I/O intensive tasks into different storage pool, and so you can keep the performance, right?
Yes. Okay, let's start this demo and just jump back to the slide.
So we have explained this, right?
Yes. So let's go back to the topic that we want to discuss about is why we choose to develop iSCSI JBOD. We just mentioned 2 job paths when you use NAS and iSCSI target and NAS with traditional JBOD. So right now, combine different solution. As I mentioned, QNAP, we always want to have a complete solution for the user. So we have provided this iSCSI JBOD feature, which allow user to use iSCSI technology to mount a remote QNAP NAS long as a storage, while at the same time, think that storage as a local disk, so that it can be used to create storage pool, create snapshot, use with QSearch. And together with all those benefits, you can more utilize the storage space between different QNAP NAS.
So basically, it's no difference like you are installing a new drive into the NAS. It's just the iSCSI JBOD will look like a new drive, right?
Yes. For this chart, we can show an example that the user have purchased a chip TS-A31X to be a storage that can be used, like the other QNAP NAS can be used as an expansion unit, while at the same time, we can also still host in some container on this storage unit. So we believe this BJBOD function is very flexible and is the expansion solution that will provide the highest ROI for our users.
So you can fully utilize your investment. The space won't go wasted.
Yes. So another benefit of using iSCSI JBOD compared to traditional JBOD is because, as we know, traditional JBOD have only one connection, and when this one connection fail, what happens? The storage will become fail.
Yeah, you don't want that.
Yes, we certainly don't want that because as a storage vendor, we always want customer data to be well protected. While using BJBOD, we can utilize the technology advantages of Ethernet solution. So, for example, we using the BJBOD, we can using the port trunking technology, which you can have, for example, the A31S. If we have a 2 Ethernet port, you can connect both Ethernet port and using the load balance port trunking mode. So now, even one Ethernet connection is down, the JBOD's expansion storage port will still be online. And with more advanced switch, you can also using the load balance mode or even allow the NAS system to evenly distribute different I/O load onto different network, so the storage performance can be even better than traditional JBOD.
So it's always better to have backup. So you have two network wires connect to the NAS. So one fails, you still have another.
Yes.
So it's like we always tell our users, you need to have backups to backups. So with all this internet connection, we still have backup. The other one, so one fails, we still have another. It's the same concept, right?
Yes. And another thing that our user may ask is that compared to traditional JBOD, the connection between 2 NAS with internet might not be so safety because some traditional users don't believe in internet. But right now, while developing VJBOD, we have implemented more advanced technology to the VJBOD function. First of all, we have enhanced the iSCSI connection of VJBOD. Is that compared to traditional iSCSI initiator, even after iSCSI target have been disconnected for 1 minute, it will not know it. So the application will still write data into it. So it might cause some data inconsistent. While using the system automatically detect when VJBOD unit is maybe be disconnected or storage have issue, and it will auto disconnect in 30 seconds, which improve this sensitive improvement will allow the IT admin to better control the connection so that the data consistency can be maintained. While secondly, we also allow the VJBOD connection can be automatically reconnect when the host NAS find the VJBOD unit. So because we use as you can see from the slide, we use the MAC address to search the VJBOD unit. So even if the VJBOD target, the expansion unit is disconnect or change IP, whenever it is reconnected, our NAS will automatically recover the VJBOD unit.
So you are having a better protection to all these things, because if you keep transmitting data to a iSCSI LAN or expansion unit which is lost, power loss or disconnected, it will cause the data inconsistency, even corruption, so your service will be disrupted. So with this, the system will sense all these changes and cut off the data transmission, so you can keep your data consistent and you can detect all this problem pretty quickly.
Yes, and auto recovery. Auto recovery is also very important because although we generally recommend our users still use dedicated network when creating VJBOD environment, if users just don't have the dedicated network environment, sometimes network ingestion may also cause the VJBOD to disconnect because the network just cannot connect. But we have this auto recovery mechanism so that even when network is congested, your storage will still auto recover itself when the network is go back to stable.
So in general, all these features reduce IT guys' workload, right?
Yes.
Very good.
So we all benefit of iSCSI VJBOD, and user may ask, can I use traditional JBOD and VJBOD at the same time? Of course we can. So this slide we show that, for example, 8-bit NAS, while using the traditional JBOD, you only have maybe 4 expansion unit because the maximum it has the port number limitation. So maximum is just 300 terabyte. While combined with the VJBOD solution, we can, for example, for this chart, we can use the recommend NAS to expand this tower NAS capacity. So in the end, it can reach 1 terabytes per row capacity.
Wow, that's really a very huge super storage space.
Yes.
And that pretty much solved the third concern I just raised. We want fast, we want reliable, we want it big enough. And I think 1 terabyte is pretty big enough.
Yes, it's really big. And with such big capacity, some users may also consider about the backup solution. So another benefit of VJBOD, one of many benefits, because right now we are still studying VJBOD is a unique technology, and no other vendor provides such solution. So they have some interesting case reported from our customer. For example, one of our customers has currently, while using the VJBOD as an expansion unit, he just find a benefit is that if you have a VJBOD, the VJBOD can help to hosting the backup task when you need to back up to a remote storage system. From this chart, we can see that, traditionally, when you need to back up a data storage and with a JBOD, the data stored in the JBOD also need to go through the host NAS and finally go to the remote NAS, which is sometimes may affect the host NAS service and performance. While using VJBOD, the VJBOD can directly host a long backup job and transfer the iSCSI long that be mounted as a remote directly to a remote NAS. So using the JBOD resource to back up the data in the JBOD, this is one of the benefits of user feedback.
Well, that's very interesting and also very useful because the expansion enclosure doesn't have any processing resources.
Yes.
So all this job relies on the host NAS. So, but with VJBOD, the expansion closer is actually a NAS itself, so it has processing power to take care of to offload some works from the host NAS.
Yes, we also encourage user to try more interesting configuration when using VJBOD because it is rather new to us, even it's already released for 1 year.
If you found anything new, any new use cases, please let us know.
Yes.
So that pretty much solves the three main concerns I just raised. But can you give us a quick recap about what we just discussed? The fast speed, reliability, and the big space?
Yes, of course. So in the final slide, I want to recap the topic that we talked about today. Is that as QNAP, we know that small and middle business always want to pursue a solution that have the highest returns on investment. And we know our customers think that, and our development team, PM team, our chairman also know this requirement. So when we design our NAS, when we design our feature, we always want to have a more integrated solution that user can solve the user's case once and for all. So today I have introduced first of all Qtier 2.0, which can replace SSD cache for general user because you have IO awareness and theory on demand, so our user can maximize the ROI when purchase SSD. And secondly, even our most entry-level NAS, if it exists 6 bay, and it also always support RAID 15 and 16, which increase the NAS performance. So if you have a NAS unit, for example, 163 that I just demo, you also use a RAID 15 configuration. With such NAS, you can use RAID 15 and 16 to provide a better protection for your NAS.
So to quickly conclude this presentation, I would say we are trying very hard to bring our users the best value of their money by providing all these leading technologies, right?
Yes, and of course we have a unique iSCSI VJBOD function which allow our NAS to utilize all of the space of the other QNAP NAS, and also we have the iSCSI initiative. Not only QNAP NAS, the other NAS, if we have any unused space, can also be utilized by our NAS.
So with all this speed, reliability, we still have great functions to expand our capacities.
Yes.
And that doesn't matter what kind of storage space you are using on the other servers, because they can all be included into our NAS as a storage space.
Yes. So protection, performance, and flexibility in expansion is the topic we are discussing today. And finally, which I just mentioned again, this Qtier storage port, Qtier 2.0, RAID 15 and 16, and iSCSI VJBOD are all unique technology that in our market segment, only QNAP have provide such technology to maximize users' ROI when purchasing storage units.
All right. Now that we know all these QNAP exclusive technologies, I must say thank you to our RD guys. They are doing a very fantastic job. So thank you, Ripple, for bringing such an informative presentation today. Thank you very much.
And it is from besides from iSCSI VJBOD, Qtier 2.0 and RAID 15 and 16 will all be released in our latest 4.3.4, which is expected to be released in the end of this month.
All right. Well, we are already really very looking forward to that.
Yes.
All right. Thank you, Ripple, for such a fantastic presentation. And that pretty much concludes our live streaming today. Thank you for watching. And for this week, we don't have any more presentations, but stay tuned for next week. We will be introducing more fun stuff and some useful tools to relieve IT guys' workload. Stay tuned. Thank you for watching today. Bye-bye.
Bye-bye.